This is the story of British Midland Flight 92. On the 8th of January 1989, a British Midland Boeing 737 was to fly from Heathrow to Belfast International Airport with 126 people on board. The plane took off at 7:52 p.m. and Flight 92 first climbed to 6,000 feet. Then it was cleared up to 12,000 feet, and finally it was cleared up to its cruising altitude of 35,000 feet. The 737 climbed to 35,000 feet as the plane flew towards the city of Trent. At 8:05 p.m., as the plane climbed through 28,300 feet, the crew felt a bit of vibration and they smelled smoke. In the cockpit, they could hear a sort of rattling, but so far the instruments did not show any signs of a fire. The captain disengaged the autopilot and took control of the plane. He scanned the instruments to see if he could discern what was wrong. He could not. He felt that the smoke was coming into the cockpit from the cabin. The captain, at this point, fell back on his knowledge of the 737. According to the captain, the 737's cabin was pressurized with air from the right-hand engine, or engine number 2. So, the right-hand engine must be the one in trouble. The first officer had been monitoring the instruments. When asked by the captain about which engine was the one in trouble, the first officer said, "It's the le." He stopped mid-sentence and said, "It's the right one." The pilots disengaged the autothrottle and put engine number 2 into idle. This seemed to solve their problems. The vibration eased up and it seemed like the worst of the flight was behind them. After they throttled engine number 2 back, they got in contact with London ATC. ATC wanted to know where the crew wanted to divert to. East Midlands Airport was quite close by, and they would be able to get to the airport quite quickly. They contacted British Midlands employees at East Midlands, and they advised the crew to divert to East Midlands. With that, their minds were made. As the plane made its way back, it was experiencing vibrations higher than usual, but in the cockpit, the plane seemed to be in okay shape. In the cabin, the passengers could hear thuds and rumblings, and they smelled smoke. The captain at this point made an announcement to the passengers. He told them that they were having issues with the right-hand engine and that they'd be landing soon. This confused some of the passengers. They could see flames on the left-hand engine. London ATC handed Flight 92 over to Manchester ATC. As the plane approached East Midlands, the captain flew the plane and the first officer handled the radios. Both pilots were engrossed in their tasks as both worked to get the 737 back on the ground. The captain wanted to review their situation. He started to say, "Now what indications did we actually get? Just rapid vibrations in the aeroplane?" But his inquiry was cut short by ATC giving them a new heading. By the time the 737 was 15 nautical miles from the runway, the single-engine approach checklist had been completed. When it was 13 nautical miles away, the plane was lining up with runway 27. As Flight 92 made that turn, they added a bit of power to the left-hand engine, and the vibrations returned. Flight 92 was asked to descend to 2,000 feet. The pilots brought out the flaps first to 2 degrees, and then 5 degrees. They also extended the landing gear. The plane descended towards runway 27. When they're 2.4 nautical miles from the runway, the plane was at 900 feet and descending. Suddenly, there was an abrupt drop in the power produced by the left-hand engine. Runway 27 was within their reach, but they needed just a little bit more thrust to get to the runway. The captain immediately tasked the first officer with restarting the right-hand engine. The captain, meanwhile, pulled back on the yoke, raising the nose in an attempt to coax a bit more distance from the stricken plane. 17 seconds after the loss in power, the fire warning came on and the ground proximity warning followed it not long after. As the 737 strayed from the glide slope that they were supposed to follow, the pilots got glide slope callouts from the automation. They knew that they were below the glide slope, but they couldn't do anything about it. Knowing that an impact was imminent, the captain got on the cabin address system and said, "Prepare for crash landing." 2 seconds later, the plane slowed to 125 knots, and the 737 stalled, crashing just short of the runway. The jet narrowly missed a major highway, coming to rest in the woods near runway 27. Unfortunately, 47 people did not make it. The 737 that had crashed was brand new, with just a few hundred hours of flight time under its belt. They needed to find out what brought Flight 92 down. When they went over the flight data recorder, they were in for a shock. The pilots had shut down the wrong engine. The data was clear as day. The engine on the left-hand side was the one generating all the vibrations and was the source of all of their troubles. But the pilots instead shut the right-hand engine down. Why? Could the instruments have misled them? In the cockpit, there are gauges which measure the vibration of each engine. With just a glance, you would be able to tell which engine was in trouble. The investigators found out that those gauges were working as intended. So why did two experienced pilots shut the wrong engine down? Listening to the CVR, they heard something interesting. When asked which engine was at fault, the first officer started to say left, then quickly corrected himself and said right. It might have been hard for him to read the gauges because of all of the vibrations. He was so close to getting it right. Then when the captain said throttle it back, he pulled back power on the right-hand engine, the engine that was working fine. The captain was also convinced that the right-hand engine was the one to blame. He felt that the smoke and fumes were coming in from the cabin, and remember, he thought that the cabin was pressurized with air from the right-hand engine. And that would be true for other planes that the captain had flown. But for this particular plane, the cabin was also pressurized with air from the left-hand engine. Now, the crew were convinced that the right-hand engine was the one at fault. If they had just taken a few seconds to study the instruments, then they would have had their answer. But this crew reacted too quickly. But that doesn't explain everything. In the accident, when the pilots pulled back power on the right-hand engine, things got better. If they made the wrong choice, then why did the problem seemingly go away? Shouldn't things have gotten worse? When they pulled back power on the right-hand engine, they also disconnected the autothrottle. This meant that the left-hand engine was producing less power than before, so it allowed the engine to stabilize a bit. But it was still vibrating. The gauges still showed excessive vibrations, and pilots in the cabin could feel the vibrations. But those vibrations were less noticeable in the cockpit. Therefore, they thought that what they had done had solved the problem. The gauges were still telling them that the left-hand engine was vibrating too much. Why didn't they notice that? Well, the captain had been flying other planes like the DC-9 for most of his career, and on those planes the vibration sensors were kind of unreliable, so he's not used to using that information in his decision-making. The first officer had no experience with turbofan or turbojet aircraft before the 737. Therefore, he didn't notice the odd readings either. In addition to that, their training was also lacking when it came to the use of the vibration gauges in fault diagnostics. In effect, they just didn't check the gauges because there was a gap in the training that they had received. Something interesting that they had found was that people just didn't like the new gauges. As mentioned before, the 737-400 was a new airplane, so it incorporated fancy new digital gauges. Gone were the old mechanical gauges with needles and stuff. But not everyone liked this. An informal survey found that 64% of pilots liked the old mechanical gauges with full-length needles. You see, on the new system, the analog needle was substituted with this small, thin digital line, which was hard to read at a glance, making things harder for the pilots. When the gauge showed maximum vibration, the digital indicator was near the word oil, which was in bright white letters. Some pilots were not a fan of this. By the way, what's more readable to you, digital or analog gauges? Let me know in the comments below. Even at this point, the situation was salvageable. That was until they shut the right-hand engine down. Up until this point, if they had caught their error, they could have just throttled the right-hand engine up back to full power. But now that they've shut it down, they'd have to go through the entire relight process. Then from this point out, the pilots were overloaded with work, from ATC communications to reprogramming the flight computer, etc. No one noticed that they had shut the wrong engine down. By the time they did realize what was happening, the plane was flying too slowly for a windmill restart of the right-hand engine. What was the root cause of their problems? What went wrong with the left engine? Up until the start of the heavy vibrations and the compressor stalling, the engine worked fine, no problems whatsoever. But when they reconstructed the engines, they found that blade number 17 on the turbine showed signs of fatigue. They found that this fan blade's outer panel had separated. Now, the report says that this broken shard got trapped in the engine, but it doesn't give specifics. Those images were missing. Mentor Pilot says that it embedded itself in the cowling of the engine. So we're going to go with that because he knows what he's talking about. This threw off the delicate balance of the engine, causing it to rub up against nearby seals, disrupting the airflow in the engine. This is what caused the vibrations in the engine, and this was the source of all of the smoke and smells throughout the plane. Then, right before landing, when the pilots commanded more power from engine 1, the engine died because that shard fell into the engine. Before, it had been embedded in the inner wall of the cowling. Now, it was free to catastrophically damage the engine. In fact, they found pieces of this panel in the flight path of Flight 92. Now, you might be wondering, wait, metal fatigue on a brand new plane? Usually, metal fatigue only shows up after the plane's been through a few years of flying. But as they found out, the CFM56 had a fatal flaw. They had found similar fatigue cracks on other planes as well. When the engine was certified, they had to prove that the fan blades were free from all unwanted vibratory stresses. But the thing is, most of those tests were conducted at sea level. Sea level air is not representative of the air at high altitudes. As it turned out, if the engine was at a high power setting at high altitudes, it could cause vibrations in the blades that could damage it over time. But these were not caught in the certification tests of the engine. Most people's takeaway from British Midlands Flight 92 is that it's the accident where the pilot shut the wrong engine down. It's so much more than that. It's the crash where pre-introductory engine checks were lacking, the crash where new technology made things harder, and the crash where workloads overtook the pilots. Which of these factors do you think contributed the most towards the accident? Thank you for watching this episode of Mini Air Crash Investigation. If you like the videos that I make, do consider liking and subscribing. It will really help the channel grow. I'll catch you guys next time. Stay safe.